us try this example. You are asked to prove the Laplace transform of sine AT equals to A divided by sine square plus A square. In fact, this formula is given in the tables of Laplace transform. The questions require us to go through the first principles in order for us to obtain the final solutions of the sine AT. To do so, you will have to substitute this sine AT into the formulas for the Laplace transform here, which will give you this. You will have two functions in the integrations. With that, you will have to integrate the functions by part. Take u equals to sine AT and dv equals to the remaining of the functions, which is e power of negative st dt. With the u here, differentiate u to get du equals to a cos at dt. With the dv here, integrate the functions, you will get v. Use the formulas of the integrations by part. U, v, v, du. That means integrations of this will give you this outcome. From here, you will need to do one more step of the integrations. This can be rewritten in the form of this. And again, this is a multiplications of two functions. To solve the integration here, you will need to do the integrations by part again. Let u equals to cos at, while the remaining will be the dv. With the u here, differentiate u over dt, and with the dv here, integrate it in order for you to get the v. Next, use the formulas of the integrations by part, which you will get u, v, v, du. Substitute the relevant value, you will get this. Based on the calculation step here, integrating this will give you this. You may just substitute in the positions of the integrations. Remember to put entire outcome in a bracket. Expand the bracket here, you will get this. What you see after you have done the integrations here, the functions now has transformed back to sine AD. This part is actually exactly the same as the one that we want to do integrations at the earlier on. You may move this to the opposite side of the functions, which give you the integrations of this on one side while the remaining on the other side. Factorize this, take out the integrations. What is left over, it will be this. Bring this to the opposite and rearrange this into this. These functions can be rewritten in this manner, where the s here can be cancelled out with the s within the functions. The remaining of the s will be multiplied with the relevant sine and cos at. The simplified outcome will be this. Based on the outcome here, we know that if you want to integrate this, you may just simply substitute the outcome into the function here. The integrations of this has a boundary conditions. Therefore, remember to put in the boundary conditions. Substitute the upper boundary into the functions and then minus with the lower boundary substitutions into the functions. Solve the functions. You know that e power of infinity will be equals to 0, while e powers to 0 will be equals to 1. Solve the integrations, you will get this. This is the exact outcome that you are asked to prove in the questions.